Cryptographically properties of random S boxes. Konstantin Lisickiy. Formulation of the problem. In this work, the task is to summarize the available information of random permutations and justify the prospects of their use in construction symmetric block ciphers with improved dynamic rates of arrival and random permutations. Literature review. It should be noted that there are practically no foreign publications devoted directly to random S box in Google. There are only publications with our participation 7, 8 and work with references to the use of random permutations in ciphers. The bulk of the work is the work devoted to the methods of forming S box structures with improved cryptographical indicators 12, 14 and many others. In work 15, a large number of publications in this direction were analyzed in sufficient detail. In this site works new techniques for the forming construction of S box with improved cryptographical indicators are considered, and there are even works of the selection of random substitution using a system of criteria close to our proposals. Only all the same, in this work we are talking about the selection of permutations according to strict criteria, and we will be talking about checking substitutions from the hour of the random substitutions generator, and our criteria will be significantly milder than the proposed ones. Going back to the analysis of the results of the noted works, we immediately use here the conclusions of the second section of 7, which fix the position at the time of their implementation. They come down to the following. First, the current approaches to the construction of S box for symmetric block ciphers and primarily aimed at ensuring minimum values of the differential dp max and linear probabilities LP max, and in the direction significant success has been achieved. S box construction with limit and theoretically minimum possible values of dp max and LP max close to them were implemented. Second, there is a theoretical develops aperture for evolution cryptographical indicators of Boolean function with the help of which you can describe the transformation carried out by S box. The approaches and rules by which the resulting cryptographic indicators of individual Boolean function included in S box can be converted into indicators of the entire transformation as a whole. Also, very much attention is paid in the literature to the development and application of Boolean function to the mathematical approaches of S box for evolution cryptographical indicators. Nevertheless, the algebraic approach of S box construction actually used in ciphers has not become described. Moreover, the S box construction used in modern ciphers have far from the best in some indicators, and in some of them even lower cryptographic properties of the Boolean function included in them. Therefore, the main indicators are actually optimized to the determinant of the secondary ones. These basic indicators include the value of the maxima of the differential and displacement sigma uniformly and non-linearly, as well as the values of algebraic degree and, more recently, the value of algebraic immunity. If the value of the maxima of the differential and displacement sigma uniformly and non-linearly can be determined without the apparatus of Boolean function, then the last two indicators, algebraic degree and algebraic immunity, already require the use of the mathematical apparatus of Boolean function. Third, the result obtained indicates that good S-box is S-box with high cryptographic indicators, at least with respect to the main group of the criteria 1. As a rule, can be obtained by exhaustive search methods for S-box of degree 256 byte S-box is very difficult, requires significant computing results. Therefore, all real developments to build large byte S-box were initiated based on methods that could most likely be considered regular. So in our works of that time, it is noted that the use of separate sentences available in publication, in particular proposals of K. Nuremberg 13, looks more progressive for building S-box. They found practical application is the science. S-box used to criteria many modern block symmetric ciphers, Rigendale, Camellia, ADE, Labyrinth and some others. In the IDNXT cipher, we took the path of building byte S-box based on the use of a 3-byte composition block, followed by the selection of the best candidate and the like. The elapsed time has made adjustments to the current state of the issue. The time has shown that random S-box really deserve more serious attention, as was noted above. In the verse recalling that then developing the new standard of Ukraine for the Kalina ciphers, the developers have already taken the path of using S-box selected from randomly generated permutation with higher nonlinear indicators compared to regional ciphers. We supplement that conclusions with one more. First, the experiment performed shown that almost all S-box used in modern ciphers do not fit into frames of S-box and random type. A brief overview of our results. We first recall the results of studying the laws of distributions of inversions, increases and cycles of random permutations of degree n more than 4 and reduced to 16 bits inputs of models of modern ciphers, our work 16th. It was found that they are distributed in accordance with the theory of random permutations according to the normal laws of probability distributions with corresponding numerical characteristics determined by the degree of permutations 17. On the basis of these results, the concept of random permutations was introduced, which was associated with checking the correspondence of combinatorial exponents of substitutions. The number of inversions increased and cycles with the numerical characteristics of the asymptotic distributions law of these exponents for random permutation 7, 9 and 18. Next, the distributions law of differential and linear exponents of permutations transformations 19, 12 were established with a refinement 21. We recall here the theorems brought in 2021 that determined the distributions law of transitions XOR of random permutation tables and the distributions law of displacements of linear approximation tables of random permutation from the work 19. Statement 1. For any non-zero fixed delta x and delta y belong that, assuming that the substitution P is chosen equally from the set S and K that more than 1 and less the 2 power to m minus 1, you see the expression 1, where the function f from D is determined by the expression 2. Here, delta x and delta y are the input and output differences of the encryption conversion. In 22, it is shown that formulas 1 and 2 corresponds to an approximation in the form of a Poisson law of a probability distributions of XOR transmissions of table of random substitutions. From our work 20, theorem 1. Let lambda from alpha beta be a random number that corresponds to the value of the cells of the linear approximation table of the substitutions when the substitutions P is chosen equal from the set S and the mask alpha beta non-zero. Then lambda from alpha beta for all values of K, then K more than 0 and less than 2 to power n minus 1. It taken only even values and the probability lambda alpha beta equals to K, determined by the expression 1. In the work 23, it is shown that formula 3 are approximated by the normal law, which can be considered theorem 3 of the robots. Here you will go for number 2. Theorem 2. For a random n-bit substitution with n more than 5, the imbalance of the approximation in a random value with a distribution that can be approximated as formula 1 for z even and 0 for z odd. If we substitute z that equal to x in 4, then it can be rewritten as next formula. That is, the imbalance equal z and z equal to k corresponds to the value of the cell in the lot table. Algebraic indicators of random S-box. Some answers to our questions were found in the publications of the journal Discrete Mathematics 28. From the article cites in this edition, Horodilov dedicated to the presentation of Boolean properties and their relation to the methods of cryptanalysis. We want to highlight a few theorems which are given below. First, about the nonlinearity of random functions in the notation of robots 28, theorem 6. Here you will go after number 3, theorem 3. There is a constant C that less than 1, such that for almost all Boolean functions f of n variables, the conditions hold next expression. For example, for n is equal to 8, C lower than 0.7 is obtained n that more than 128 minus 32. The most probable nonlinearity of random byte S-box obtained is experiments is 128 minus 34. It is known that the nonlinearity of the arbitrarily balanced function is the case. Finding specific function with high nonlinearity is a non-trivial problem. Use some kind of time-bound, very complex methods of next expression. For n is equal to 8, is turned out n is less than 118, but it is noted in 28. It is often f. Construction such function. They draw following of the path of filtering random S-box using sufficiently large computing resources. It is noted that the algebraic degree is a natural upper bounded for the algebraic community of the IE Boolean functions f. In addition, the following upper bounded of algebraic community depends on the number of variable n of the Boolean functions. This is theorem 11 in 28. Here she will go to number 4. Theorem 4. For an arbitrary Boolean functions f from n variables, the conditions i.e. where k is the integer path of the number k is satisfied. It is known that this estimated inachievable for n is equal to 8, i.e. less than 4 is obtained. Also, there are examples of functions with maximum algebraic immunity. It is known that this class of functions is very small. However, an interesting fact it is the algebraic immunity of arbitrary functions is quite high. Theorem 5. For any alpha that less than 1 and for almost all Boolean functions of n variables, the conditions is satisfied as next expressions. For n is equal to 8 and alpha is equal to 0.7, I is more than 4 minus 2.9, and it is equals to 1.1 is obtained. Theorem 14 of 28 gives a known exact lowest estimated of the nonlinearity of a function due to its algebraic immunity. Here she will go to number 6. Theorem 6. The Boolean functions f of n variables and f are estimated. You see next expressions. For n is equal to 8, it turns out n that less than 58. Unfortunately, the results appear to be very blurred, but we couldn't find anything more specific. In 28, a very important conclusion is drawn for us. The theoretical results shown that in the random Boolean functions more cryptographic parameters are close to optimal ones. Table 1. The distributions of the values of the maximums of the simple XOR differences of the substitution of degree 2 and degree 8 obtained by calculation and experimentally. You see the next table. From the presented results, it is follows that theoretical and experimental results practically repeat each other. This means that for the distributions of differential of byte substitution, the Poisson probabilities distribution law, which was used in construction the internal law of distributions of maxima for this substitution, is indeed fulfilled. The distributions of values of the maximums of displacement for the set of byte substitutions calculated 2 in degree 8 obtained by calculations and by experiment. In most cases, the offset maximums for linear tables of byte substitutions are 32, 34. From the presented results, it follows that the substitutions with a maximum displacement value of less than 36 are 94. Finally, it will be appropriate to give the results of experiment with random byte S-box obtained in 27, which are shown in table 3. 10 million random substitutions were generated. The table in breaks also shown our experimental results, but not for all criteria. We are particularly pleased with the indicators of algebraic immunity. According to our data, the S-box of the IS ciphers has algebraic immunity too. Discussion. The results of the studies confirmed that the substitutions from the output of the random permutations generator are likely to be good S-box. But given the still little experiments of using random substitutions to build ciphers, and being quite criteria of this model for some specialists, it is suggested that an advanced random substitution model be considered as a random substitutions from the output of a random substitution generator, which passed a positive check for compliance with at least 4 indicators, S-box and Boolean functions that form it. First, maximum value of the XOR function it in the range of 8, 10. Second, the maximum value of the displacement of the last, it is in the range 32, 34. Third, the algebraic degree of Boolean functions of the S-box is not less than 7. And next, algebraic community index of S-box is not less than 3. It is a random substitution obtained without restrictions, very likely to be suitable from the point of view of cryptographic applications. They have provided the best dynamic output of ciphers with strong linear transformations. To asymptotic indices of random substitutions, the ciphers of such constructions, which allow to increase the minimum number of activated S-box of the second cycles almost to the maxima, is over in 3. Thus, the scientific novelty of this work is seen in the fact that for the first time the possibility of using S-box for the constructions of ciphers from the output of the random substitutions generator is substantiated. Conclusions. The main result of the work is a refined model of random substitutions. According to this model, a substitution is considered random if it belongs to an ensemble of substitutions whose maxima of XOR tables and or set of linear approximation tables obey the law of distributions of Fisher-typed extreme value. This allows random substitutions in ciphers to be used directly by substitutions formed by a random permutation generator. The refinement concerned the use of additional selections criteria, which, as it turned out, do not substantially limit the many substitutions formed by the random generator. At important conclusions is that for a random Boolean function, most of its cryptographic parameters are close to optimal. It will be natural this conclusion to random S-box. For randomly taken S-box, most of its cryptographic parameters are close to optimal. As a result, the problem of construction ciphers in which random S-box can be used without loss of stamina becomes relevant, which found its first solutions of our work 3 and its several others.